In this example, we're dealing with the standard steel shape. Okay, in this case, you do not need to calculate the moment of inertia of this I-shaped steel beam. Okay, it had been given in a table. So in your future job, perhaps you need to design something and select the steel members. Then you will be able to find these values from big tables provided on either manuals or design codes. Okay, so here let's just find out the useful information from the table to do the calculation. Okay, so here we have a steel shape. Standard steel shape is strengthened by two plates on bottom and top. Okay, the sides of the plate have been given. Now, what is the moment of inertia about x-axis and the y-axis? So we're calculating Ix and Iy. Okay, so this shape is symmetric both about x and the y-axis. So you can calculate both Ix and Iy. Right. So from this table, we have find this standard shape, and you can see that its Ix is 60.8 million millimeter to the fourth, and its Iy is 20.4 million millimeter to the fourth. Okay, these are the two useful information. And we also need to find some other useful information, like a T, like the thickness, the sizes here, their sizes here. Okay, we also need to find out these informations from this table. Okay, this is area here, and the depth D is 210. Okay. Okay, based on this, let's summarize the information that we have got. Okay, for the table, from this table, we have got the wide flange beam. This is called W beam. Right? It's called a wide flange beam. For this one, is Ix. Let's call it Ix wide flange W. This is 60.8 million millimeter to the fourth, and Iyw is 20.4 million millimeter to the fourth. And we have also found that its depth D is 210 millimeter, and its area is 7550 millimeter square. Okay. And for these two plates, we need to do some calculation. Right? So the B shown here, B equals 250, and the T is just 10. Right? Then what is the area? Area would be just 250 times 10, right? 2,500 square millimeter. Then the Ixp equals what? Ixp, shown here, the x-axis, local x. Ixp would be bt cube over 12. Right? Bt cube over 12. That is bt square. For that is 800 millimeter to the fourth. And Iyp will be T b cube over 12, because b is a large number. So this will, you will get a large number that will be 13 million millimeter to the fourth. Okay, from this information, we can calculate the Ix and Iy. Look at the Ix. Ix, just use our equation. That will be sum ICX plus AI di square. Table. For the W, wide flange beam and plate. We have this two subsections, 2 plates. We calculate 1, then multiply it by 2. It will be fine. Here we will need AI, DI, and ICX. So what is a wide flange beam, AW? AW there is 7550, and A plate is 2500, and the DI is here. DW is just from the overall centroid. The overall centroid and local centroid will be together, right? So this will be 0. About DP from this local centroid to the overall centroid, it will be half T plus half D, right? So half T, that will be plus half D. This will be 5. This is T equals 10. So this is 5 plus D, the depth here, plus 105. So this will be 110. Okay. Then the ICX, these have been determined for the W. This will be here, 60.8 million. And for the plate, here is 20,800. Okay. Then we can calculate that. So here, this is the AIDI square plus ICX. Okay. This will get, just since DI equals 0, this is a 60.8 million. And here you will have 33 million. Okay, so based on this number and this number to here, so we will have 60.8 million plus 33 million. Don't forget times 2, right? Since you have 2 plates, okay, 2 plates strengthening this beam. Okay, add them together, you will get 126 times 8 million millimeter to the fourth. Okay, don't forget times 2, right? Since you have 2 plates here. Then we also need to determine IY. IY would be sum ICY plus AI DI square. Again, just so we need a table. Here you have W, you have P, then you have A here, DI, A have been given. This is 7550, 2500, and the DI. Okay, the DI. What is DI? Right, now we're calculating IY. Okay, the y-axis is here. So your local centroid is here, here, and here, right? And the overall centroid is just here, right? Since they're all on the y direction, okay? So what is the DI? DI equals y bar. This time it's the x bar minus x. So they're all on this line. So on x direction, their distance is just what? Their distance is just 0, right? They have no distance. This axis are all together. Okay, so here would be 0, 0. ICY have been calculated. IY W is here. IY plate is here. Right, 20.4 and 13. Okay, 20.4 million, 13 million. Okay, so here is just AIDI square plus ICY. Since DI all 0, so we just get 12.4 million, 20.4 million, and 13 million. Okay, so this will be 20.4 million plus 13 million. Again, don't forget times 2. Okay, this will be 46 times 4 million millimeter to the fourth.